Question 9 says a biologist is researching a newly discovered species of bacteria. Initially, she puts a population of 600 bacteria into a favorable growth medium. 4 hours later, she measures a sample and notes that the population is 1,000. Assuming exponential growth, how long will it take the population of bacteria to reach 4,000? So this is an exponential growth problem. I think when we went through the one in class, there was an example of exponential decay. So it could be either one. But because it's growth, I'm going to use, and you could, again, it doesn't matter if you use A or P. I think the one we did in class, we used a P for population, but again, it doesn't make a difference. Because it's growing, though, K is positive, so it's PE to the KT. So to come up with my model, I have to know that's P0, sorry, down there. I have to come up with the original amount, and I have to come up with K, which is the growth rate. So I'm going to go P of T is equal to the original amount, which she put 600 in at the beginning. But I've got to figure out what K is. And to figure out what K is, they'll always give you some other information. So it tells us that 4 hours later, the population was 1,000. So I can use that to figure out what K is. So the population was 1,000 4 hours later. And what I have now is I have everything but K. So now I should be able to solve for K. So I'm going to divide by 600. You can get rid of some zeros there. It's 10/6 or 5/3, or if you wanted to, you could change that to a decimal. Just be careful. We don't want to round things off at this point. So that'd be E to the 4K. Take the ln of both sides to get rid of that E. So ln of 5/3 equals 4K divided by 4. Okay, that's what K is equal to. So now my function, my model, is P of T equals 600 E, and now I know what K is. It's the ln of 5/3 divided by 4 times T. Now answer the question. The question actually was, assuming exponential growth, how long will it take for the population of the bacteria to reach 4,000? So that's the population. Plug 4,000 in there. And I got to solve for T. So I'm going to divide by 600. Cancel out some zeros. 40 over 6 was like, what, 20/3? Equals E to the ln of 5/3 T divided by 4. Take the ln of both sides. Those cancel out. So now I've got the ln of 20/3 equals the ln of 5/3 divided by 4t. So now if I divide by this thing, take this side and divide it by that, the ln of 5/3 divided by 4. Well, that's kind of weird to put in our calculator, but if my scientific calculator up here, it's going to look something like this. ln of 20/3 divided by parentheses ln of 5/3 divided by 4. But make sure you put that denominator right there in that big set of parentheses. Okay, let's grab my calculator right now, plug that in there and find out what it comes out to. So I got the ln of 20/3 divided by again, put a big set of parentheses, the ln of 5/3 divided by 4. Okay, we want to go out, what did it say, 2 decimal places. So it's 14.86, if I round it off, 14.86 hours. Let's plug that in there, just double check it, make sure we got everything right. Let's go back over to the actual problem itself. 14.86 is what we want to put in there. Okay, double check our answer, and then we got it.